Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5-8000 setup with the 9700X, again on the Asrock X870E Taichi Lite motherboard, which I bought, so a big thank you to the channel supporters for funding the purchase of the motherboard. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. The memory kit that I'm using is the G.skill TridentZ5 RGB Neo 2x16 8000 CL38 Expo kit. Which was provided by G.skill, so big thank you to them for sending the memory. This kit is based on Hynix 16 gigabit A-die memory chips, and this is a single rank configuration. And I originally wasn't actually planning to use this memory kit for this testing. But the thing is, the first 16 gigabit A-die kit that I grabbed didn't want to work at DDR5-8000 with the Taichi Lite, like, at all. And that kit admittedly isn't rated for 8000. It's technically, it has an Expo profile, but it's really more of a like XMP 7600 kit. And so when I ran into that, I was like, I wonder if it's the kit or if it's the board or like whatever. And so the easiest way to check that, in my opinion, was to just grab this 8038 G.skill kit and test that first. And I'm very happy to say that this did just work. Like, the Expo profile just works just fine. So I will be revisiting that other A-die kit, because now I have a theory as to why it didn't work. Because that other kit did do 8000 on a different board, it just didn't do it on this board. But anyway, so that's how I ended up running this G.skill kit, and since I already had it installed and I was going to stress test it anyway, because just like the other kit was mega unstable, but just because something is slightly more stable does not mean it is truly stable. So I was gonna stress test it all the way anyway, and so I decided to push it a little bit more, because the only other overclock that I've done with this motherboard is the 2x24 gigabyte G.skill kit, and that's an 8000 CL40, and I was just running that at like Expo timings for the primaries. So today we're looking at a CL34 setup at DDR5-8000, which I don't think have I done that with this kit? I don't remember. Maybe. Actually, no, I don't think so. Doesn't matter. No, wait, I don't know. I may or may not have done a CL34 setup with this G.skill kit. Either way, now I've definitely done one. That's kind of the point of doing a lot of these videos, is to just like test out different configurations. Anyway, so for stress tests, I actually ran Y-Cruncher twice, because while like shuffling the windows around for the screenshot, I accidentally closed my Y-Cruncher window. So technically it says 2.7 hours. I ran that twice. So it's like 5-something hours. Yeah, it's like 5 hours. Anyway, 9 hours of Prime 95 large FFTs and 13 hours of Karhu. Also, it turns out if you keep up with your software updates, Hardware Info can read memory temperatures on this motherboard. So that's on me in the previous video, because I complained that like for some reason I didn't have temperature sensors, and yeah, it's just outdated Hardware Info version. But I'm not sure, like the funny thing to me about that is that the 8.1 Hardware Info, which is what I was using, works on all the other, worked just fine on all the other X870 boards, so that's why I wasn't, that's why I didn't bother updating it. Anyway, with the up-to-date version, we actually get all kinds of fun readouts, like direct voltage readings from the VRM controller, which is nice, though I haven't, yet checked if they're, how accurate those are yet. As well as, VRM temperature readings, which is nice to have directly from the power stages. So yeah, ran Karhu. Now, I do have one, still issue that I'm running into, but I'm not sure if this is the motherboard, or if it's the memory kit, because technically I haven't tested this. You'll notice that the PHY RDLs are mismatched, and in the previous video I showed how you can get them to match. And I tried that with this setup, because I was like, oh, let's try 8000 CL34, try push 2-to-1 mode, kind of to its limits. Technically, I haven't yet checked if the CPU is capable of higher memory speeds, but right now I just want to sort of figure out how many motherboards can reliably do DDR5-8000. Because with 7000 series and older X670 and B650 motherboards, that was honestly kind of a struggle a lot of the time. So my priority right now is just seeing like how many times does 8000 work, because going above 8000 I really strongly suspect is more of a CPU memory controller test than it might, like, it probably still depends on the motherboard, but I'm not sure how much. But anyway, so yeah, 8000, and I was thinking like, okay, let's just try push 8000, 2-to-1 mode to its limits, and as part of that, I would like the Phi RDLs to match. But when I set, like, when I adjust the setting to get them to match, it's just completely unstable. It like crashes Prime 95 in like 13 minutes. I tried a few voltage adjustments to try see if that fixes it. It didn't. The thing is, like, I have tested matched Phi RDLs, but not with this memory kit, if I remember correctly. Pretty sure I did that with a Kingston memory kit. So I'm not sure if it's like it might be the memory sticks, it might be the motherboard. I don't know. This is one of the reasons why I do a lot of this testing, is just because sometimes, like, you sometimes just run into a combination where it does work, and sometimes you run into a combination of hardware where it doesn't work. Anyway, so that's like my one complaint for this setup here, because other than that, this was actually very easy to set up. Just turn on Expo, bump VDD to 1.65, which is, of course, why I have the fan on the memory sticks, though they're not really running that hot, as you can see. Well, that's probably the fan's fault. They maxed out at 40 degrees. Like, the combination of a single CCD Ryzen chip and a fan on the memory sticks means that memory temperatures are very, very manageable as long as ambient temperatures are reasonable, which it's winter in the UK, so yeah, they're pretty reasonable. So anyway, as you can also see from like the idle temperature being like 25, 26. So it's also not like super cold, right? Like the room isn't below 20 degrees because I'd find that intolerable. Oops. Oh, I guess I just minimized it. Anyway, I guess at this point we'll just go into the BIOS. Actually, I'll point out, so my theory for why the other 8i kit that I tried with this motherboard didn't work is because the resistances over here were just like, well, they weren't set like this, and I'm pretty sure they were just set completely wrong. So yeah, I need to do some testing on that. Anyway, let's go into the BIOS and take a look at how I got this to work. I don't think I'm forgetting. Oh yeah, there's also no errors down here. Am I missing anything? Oh, and power down is disabled, and that's just a default of the like current AGSAs, and I've not run into any issues with that yet. Anyway, though, I guess it's worth pointing out that I don't really use sleep mode on any of my systems, so if power down is broken, like if there's like an issue with sleep, I wouldn't know about it. And the reason I bring that up is like if there were to be a power down problem even now, it would probably be related to sleep, is my guess. Anyway, also yeah, memory context restore is enabled because that's just the default behavior of the AGSAs now, is just power down disable. Well, at least if you just enable Expo, I don't know what happens. I think JDEC you would still have your power down turned on, but for Expo it gets disabled. And memory context restore gets enabled, which allows fast boot up times. As you can see, I do have the CPU power limit raised to, well, the TDP set to 105, which is kind of ridiculous when you look at the power limit being 142 watts. I do not appreciate that. Like, I know the TDP is supposed to be like a cooler, like, heatsink rating. Well, I would much prefer if we just talked about actual power limits instead of magical thermal design limits. Because, yeah, like, just say what the power limit is. That would be a lot better, in my opinion. Anyway, so voltages. VDDIO at 1.4. This is actually what the Expo profile uses, which is kind of interesting that we have like a VDDIO, VDDQ mismatch. But depending on how the motherboard is designed, that works just fine. So I'm not going to question it. On MSI, I would usually set VDDIO equal to VDDQ. On Asus, you normally have to run VDDIO above VDDQ. And on Asrock, it's 1.4 VDDIO with 1.45 VDDQ, and it's happy. Now, as far as I know, a big part of this is that there's actually a bug in the Asrock BIOS where you can't lower VDDQ below 1.45 volts. So, yeah. I haven't really tested for that much. I don't really see it as too much of a problem because the way I see, especially like VDDQ, is like you just set this voltage to whatever makes the system stable, and then you don't think about it. And if that's 1.45 volts, that's cool. If it's 1.35 volts, that's also cool. So if the motherboard likes 1.45 volts, I'm happy. I do not care. And VDDIO at 1.4. Like, I did actually try raising this when I was trying to get the PHY RDLs to match. And yeah, that didn't help. I also tried more like SoC voltage, and that also didn't help. Well, I didn't try more VDDP. So I might need to do more testing on that. The thing is, like, more VDDP in my experience, like, I am not sure why change, like, I can't think of a reason that changing VDDP should help. So, unless I'm misunderstanding what the PHY RDL timings are about. Which actually, on that note, I don't know why SoC would help, but that was just like an easy one to try. Because the thing with VDDP is that this is one that sweet spots very, very hard a lot of the time. So if you like set it a little low or a little high, it just stops working. And the 1.05 volts, that's the default from the motherboard, and so that works just fine at 8000. And that's been, like, that's technically also the same value that I've used on basically every motherboard with this CPU. So, yeah, this chip seems to just like 1.05. And then again, I haven't, like, tried to push the chip to, like, above 8000, so maybe at the higher frequencies it would need a lower or higher VDDP. I don't know. I haven't tested for that. Anyway... also, VDD MISC is at 1.1. I don't even know why that's not on auto, because the default VDD MISC voltage is 1.1, so I don't know why the motherboard decides to, like, overwrite that with a 1.1. But anyway, other than that, I do have Expo turned on. So, yeah, that's how the board dealt with all of the voltages for me. And I am not sure... Like, I haven't yet checked if, like, the terminations and drive strengths change depending on if you have Expo turned on or not. But that is something I do plan to look into. Anyway, DFE retraining got turned on by Expo. I didn't bother to change gear down. Actually, I think I did try turning off gear down mode, and that made it upset too. So maybe the command address bus on this motherboard is a tad weak or something. But, anyway, timings. So, A-die. 34, 46, 38. Pretty typical, as far as I'm concerned, for A-die at DDR5-8000. Well, the CL34 is where the really high VDD comes from, right? We're at 1.65 for that. That might be unnecessarily high for these sticks. Like, it might work at 1.6. But I didn't want to spend a ton of time on like, testing it. And 1.65 volts isn't going to hurt the memory sticks, so... I'm lazy and I see no reason to change that. So that's my explanation for that. TRCD at 46. With 1.65 volts, it might do 45, maybe. The thing is, though, like, testing if like one tick of TRCD really makes a difference is kind of hard. Also, there's no TRCD WR register adjustment available on this motherboard, which is quite annoying. Then row pre-charges at 38. This could maybe do 36 at 1.65 volts. I didn't really bother to check that. TRAS at 48. This could probably go lower, but I don't really see a reason to try push it down more. Because especially once you're at high speeds in 2-to-1 mode, like TRAS can sometimes show up as like a stability limiter, and it doesn't affect performance that much. TRC's at 86 because it's just TRP plus TRAS. TWR at 48, refresh interval at 65,000. The refresh cycle itself, 480. This is basically as low as it goes for 16 gigabit A die at DDR5-8000. Then we have the 2 refresh cycles that aren't used, so I've set them to 69 because that's nice, and they don't do anything. RTP at 12 might go lower, but I usually just set it to 12 for ADI, especially at 8000. And then TRDLNS at 8, 8, and TFAW at 32, because yeah, in 2-to-1 mode, that's usually the limit for these. Also trying to lower these. I think it doesn't work in 2-to-1 mode that like lowering these below 8. And also, even if they did work below 8, the performance benefit with DDR5 of setting the TRDs below 8 is minimal because the burst length on DDR5 is 8 clock cycles. So there's not really much point, in my opinion, to like, you know, especially when you're at like 8000 and the motherboard and memory controller are kind of at their limits. I don't see much point in trying to test if, you know, lowering the TRDs does anything. Also, as far as I know, the way for actually checking if these are being applied properly is that you have to get a memory kit that doesn't work at like TRDS4 and then or TRDL4, and then you switch to 2-to-1 mode and you set it to 4, and then it posts. It's like, oh, it's not actually applying. Anyway, because like trying to actually verify it from the performance is just an absolute nightmare. So you basically have to prove that like if these are applying from like does it stop working basically perspective instead of like does it improve performance. Anyway, WTRL, WTRS, we're at 16 and 4. SCL 8, 1 and yeah, well, SCL and SC for reads, we have 8 and 1. And right-to-right SCL and SC at 8 and 1. Though, if I remember correctly, the Expo on this motherboard actually sets the SC timings to 2, which is really bad. Because that puts a 1 cycle, like as far as I know, that would be putting a 1 cycle gap between successive read bursts, which is terrible, because that is basically deleting like 12% of your memory bandwidth. It's just throwing it right out the window. So, yeah. I guess that's like a stability hack from Asrock, but it's bad. Like it's really, really bad. Like do not ever run the SC timings above 1, because there is no scenario. Like you would literally have to clock the memory, like I think the only way to justify setting the SC timings to 2 is if you were running like DDR5-9600 or something, to offset the fact that like you're delaying successive read bursts by an entire extra clock cycle when usually they're right. Like the whole point of the back-to-back timings is that they're back-to-back. So yeah, we do not want gaps between our read or write operations. Though with the Ryzen CPU, the write operations aren't really a concern, especially on a single CCD. Because there's like 32 gigabytes per second of write bandwidth, which is not much. Anyway, write to read and read to write 4 and 16. This is about as low as they go for ADI at DDR5-8000. Now on the T-Fi RDL issues, so I showed this in the previous video, but I'll just show it again. So for trying to get the RDLs to match, there's this setting right here. You set it to manual, and then you lower this until your like sometimes they will refuse to line up. Like I've had memory kits where if you set it to 2, they're not aligned. If you set it to 1, they're not aligned. If you set it to 0, they're still not aligned because like right now the board is training 3840. I've seen some memory kits that'll go like 3840 at 3. Then they'll go 3840 at 2, and then they'll go 3638 at 1 instead of 3838 at 1. Now this kit does go to 3838 if this is set to 1, but it also immediately crashes Prime 95. Well, it doesn't immediately crash Prime 95, but it errors out very quickly, and I didn't bother to check any other stress tests at the time. So I don't know if like Prime 95 was like specifically Prime 95 was the best for testing that. But it was erroring out so quickly that I just didn't really see a point of trying to like push for that. Anyway, and the reason why you want your RDLs to match is that it improves memory latency a bit. yeah, so that's that. So I still need to do more testing with this. Like I'm mainly wondering if this is a memory kit thing that the PHY-RDL mismatch is a thing, like that I can't get rid of the PHY-RDL mismatch, or if it's just like a settings thing. I don't know. The other thing is I also want to get that other 8i kit working because yeah, like I want to know, is it like an incompatibility between the motherboard and the memory kit, or is it just like bad settings or something? So anyway, hopefully you found this somewhat interesting, and maybe even a bit useful, especially if you have an Asrock board, because I think, I mean, I'm assuming the Nova is the same memory topology as this. And actually, I'm not sure if the memory topology on this board is like significantly different from a lot of other motherboards in Asrock's lineup. And if it's relatively similar, then like, yeah, a lot of what works for me here might work for a lot of the other motherboards in Asrock's lineup. I do plan to test some B650 Asrock boards at some point, but I haven't gotten around to it yet. Memory testing takes forever. And I don't, unfortunately, have the space to just set up like 6 systems. Actually, I don't have the power supplies to set up 6 systems. Or the CPUs. Like, that would be the other issue, is like, I'd need so many chips if I wanted to run a bunch of motherboards in parallel for memory tests. But anyway, hopefully you found this interesting, and maybe even useful. And that's it for the video. So thanks for watching. Like, share, subscribe. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And that's it. So thanks for watching, and goodbye.